It was closing at 9, and now told it's closing at 8. So we really have to get going. Anyhow, my name is Hugh Dibley. I'm the chairman of the Toulouse branch. I'd like to welcome you all. And of course, we're welcoming, where's he gone? Jim Fawcett and Mark Lewis, because you may have heard that Yannick Melange was going to give us a talk, but unfortunately this year he's unable to do it. So we're very grateful to Jim and Mark for stepping in at short notice. So, if I hope I can get that on, a little bit about the background to Royal Aeronautical Society. A lot of you have seen this too many times before, but some of you haven't. But it started a few years ago, and the aim was to share knowledge. And I would, if you want the whole thing, it's further into the advancement of aeronautical art, science, and engineering around the world, which we endeavour to do. One of the reasons we're here. And people say, well, what were the Brits doing that time before? Well, George Cayley started his work in the 1790s, and he worked out from his work in his large mansion the forces, mainly, I think, if you can put it right, of lift and weight and thrust and drag. And going on from that, he actually launched a glider off a hill with his coachman on board. That's a replica with the intrepid Richard Branson on board a few years later. And the fact is also the Wright brothers said they used part of their papers in their design of their airplane, which of course made the first controlled powered flight in 1903. So the Royal Aeronautical Society, we have 67 branches in 20 countries. We have now 6 in Europe or European continent, as UK still is part of Europe. And the latest one was in Berlin. And we encourage people to join either the local branch here and the branch in London, and applications are online. Now, we are celebrating, of course, the Gordon Core Lecture, and we have Nick, which is Gordon's son, with us. And going back to the time when the branch was formed by Gordon, because he was instrumental in starting it, and that was a group that joined. We still have 2 people. Where's Bob is still with us, and we have to thank Alan Whitmott, who is actually registered online. He hasn't come today, but he kept the whole thing going in the late 90s, I think. So this is Gordon's history. He was in the RAF, flew lots of airplanes. He became the chief test pilot in the UK, and mainly in the certification of the Concorde and the VC-10. And then he joined Airbus and was instrumental in the fly-by-wire system. Initially, he was on the A300. And very sadly, he died when investigating an A300 accident in Nepal. And as a result of that, he was honored by this lecture, which is on the theme of aviation safety or flight testing. Yannick Melange would do flight safety this time. We're doing flight testing. And the lecture shield was started, which is outside. And his children, that's Nick, Debbie and Brian, and Nick is with us, have been central to supporting their father. And Nick is here tonight. He was also a member of the Académie de l'Air and l'Espace. Oops. And there is the shield, which we have outside. That's pictures of Gordon and his wife. Now, we have tonight, of course, our president for the Royal Aeronautical Society in London, David Chin, who would like to say a few words.
Thank you. Merci. Bonsoir, mesdames et messieurs. Soyez le bienvenue ici. Je suis très content d'être parmi vous ce soir. Thanks for the invitation, Hugh. So, David Chin, President of the Aeronautical Society, really delighted to be here for the first time in Toulouse. It's a great honour. I have been around at a number of branches in Europe. I set up the Paris branch, so I'm really into supporting the branches and particularly our French connections with our French colleagues. So we're a bit pressed for the time. I won't say any more, but please speak to me later on. I'm really keen to speak to members and potential members. So thank you. Thanks. Merci.
So we're now coming to our two presenters. That's in the full details are in our email shop, which was sent out, but you can just see here that Jim started in BA Systems, British Aerospace, becoming BA Systems eventually, and University of Southampton. And of course, he was here with Seeker as well. Then very shortly after being working as an engineer, he was trained at Epner in East, I think it's right, as a flight test engineer. And he's now the lead flight engineer in basically the front end of the airplane. Or is he mumbling? I don't know. Have I got that wrong? And he's a fellow of the Society of Flight Engineers. You can see up top, he's a member of the Royal Aeronautical Society and a CN, chartered engineer. And we have Mark Lewis here, who flew lots of aeroplanes in the Air Force. And of course, he flew the Harrier, which is a very demanding airplane, is it not? Very, very topical nowadays to talk about V-style airplanes, but you want to talk to Mark about doing it properly on the Harrier jet aircraft. And he was a test pilot at Boscombe Down and was a principal tutor. Then he joined Cathay briefly to fly 747s with Rolls-Royce engines. And of course, that qualified him to join Rolls-Royce. And he had 12 years with Rolls-Royce, and then he moved to Airbus. So we are very privileged, and thank you very much to Jem and Mark. There we are. So I hope it now comes on.
So, as Hugh mentions, this wasn't entirely expected for myself and Mark. We weren't expecting to be here this evening, even though it's a great pleasure to be here this evening. We had a phone call a couple of weeks ago asking if we could help out. And I found myself scrambling for knowledge about your father, because even though I've been working for Airbus for now 30 years, I never had the privilege to meet your father. And by an unbelievable coincidence, I opened a book which I received in my Christmas presents this year, which is by a previous flight test engineer from the UK, John Smith, which is full of interesting anecdotes about his time working in the UK, including at the CAA and including with your father. And I hope you won't mind if I share one of the little anecdotes which he has in this book. Many of them seem to be involving going to the pub, so it won't be one of those. But this one is about an incident which Gordon had flying in the States, so he's flying as a CAA pilot. It writes here, he'd been involved in an evaluation on the Gulfstream II, and Gordon was flying from the left-hand seat as usual. During a normal takeoff, they encountered a flock of large birds, some of which entered both engines just as the aeroplane was about to get airborne. It sounds familiar, doesn't it? At that stage in the takeoff, they were above V1 and strictly should continue the takeoff. Gordon made an instant decision as he had no idea whether either or both engines were still capable of producing significant thrust. He closed both throttles, put the aeroplane firmly back on the runway and stood on the brakes. Even at that speed, there was just sufficient runway left to complete the stop. I heard later that the Gulfstream test pilot and others on the flight deck burst into an impromptu round of applause. And apart from 2 damaged engines and some very hot and worn-out brakes, they had Gordon to thank for still having themselves and their precious aeroplane intact. So I think that's a nice little story about the character of your father and some of the work he was doing. We're going to get started, but I just wanted to point out to David that the Toulouse branch is, in my opinion, one of the most international branches which there are. There are plenty of people here from the Toulouse area, but there are people from much further afield. I cast an eye in the middle of the theatre here. We've got people from Canada. I can see some friends from Airbus Washington office in the back of the room as well. And if I believe the sign-up list for the online, I think we've even got people in Auckland in New Zealand on the course. So if you're online and you're not out of bed yet, then maybe it's the time to get started. So I hope you enjoy our presentation, and Mark will kick off.
So good evening, everybody. Guests in the room, guests online, President of the Society. As Jim said, it's our pleasure to a little bit towards the last minute, but we've had enough time to gather our thoughts. And what we'll aim to do is give you a taste, a flavour of the new version of the Airbus 321, the XLR, or extra long range. It looks a lot like an Airbus 321, and we'll talk about what's underneath, what's inside, because there are many quite radical differences between the baseline airplane and the extra long range to enable it to do its mission, which is to essentially be a single aisle long haul airplane. So the airplane first flew in the summer of 22. Eventually we had 3 test airplanes, 3 prototypes. The first one had the CFM engines and lots of flight test instrumentation, lots of orange cables and orange equipment, as you would expect. It was followed 3 months later by the Pratt & Whitney powered airplane with geared turbofan engines. So a lot of differences to consider in terms of the operability of those different engine types, and also the performance of the airframe engine combination has to be really identified, elaborated in great detail to take into account the differences and thrust response and so on. And then finally, one more CFM airplane. That's the October 22 airplane that you see there with all the flowers at the front. And this was the cabin test airplane. The cabin, from our point of view, maybe not so interesting, but from the commercial point of view of the new airplane, given its role as a long-haul airplane, vitally important that it has a very, very good and reliable cabin so that the airline customers are happy with it. So you might be surprised to see 2 years of flying, 1,500 hours almost, and more than 450 test flights. But it looks a lot like an A321. So why all this effort and time and focused test planning, test execution, data analysis, and reporting? And we'll go into the reasons for that as we go through the presentation. Eventually, by July 24, we had certification with EASA and a lot of participation of EASA and the French DGA along the journey towards certification. And this variant, this is the first Airbus that had Autoland certified from the beginning, from certification, the first one at entry into service, which started with our friends in Spain, Iberia, in October of last year. So that was just a taste of the certification activities. For those online, apologies for the lack of sound. It's beyond our technical abilities to get the sound to work online. The only thing you missed was some reasonable music to go along with it. Okay, so here we have 2 Aer Lingus A321s. One is a normal A321, the other one is an XLR. The giveaway is in the registration, clearly. But if you look at this, unless you have a very keen eye, the differences are not so apparent. Can anyone see the main difference? Yes, yes. Yeah, you see the belly fairing in the lower picture extends much further back. So we have an extended belly fairing, and that's all part of the story of the fuel system to allow us to carry extra fuel in a rear center tank, which is in the fuselage, and the skin of the airplane, of the rear of the airplane, is actually part of the tank. And there's an interesting story and some considerations on the certification of that, which Jim will cover later on. It was a little controversial for a short time. So this is a marketing slide, but it's still useful. If we go to the bottom left, the original A321 hails back to 1992, and when it started flying, it had approximately a 3,000 nautical mile range. This diagram shows the incremental changes to the 321 family that have been trying to squeeze more performance and more range out of the airplane. So aerodynamically, by adding sharklets on the wingtips, we make a modest gain of 150 miles. A big step change comes around about 2013, 2014 with the new engine option. And of course, there are two choices, the CFM and the Pratt & Whitney. That buys another 300 miles. Eventually, we put some more fuel. There's some fuel tank options that you can build into this airplane, pre-XLR, that add in total about 500 miles. And with that, we have the A321 long range, the LR, an airplane that can just about do London, New York. But the customers wanted more. The trade studies suggested that more was possible. And so the progression was made to the extra long range with additional fuel tanks, a significantly heavier max takeoff weight, and therefore a lot of modifications to cope with a greater range of weights, centers of gravity, and greater range. So 700 miles extra, and depending on how we calculate the final figure, it's in the order of 4,700 nautical miles, which is a long way on a single aisle airplane. So the dotted red lines on this slide show you some of the customer chosen routes for the airplane. So you could go from London to New Delhi in an A321 now, or Rome to New York. Missing from the slide are some of the South American options. So American Airlines, for example, will fly from East Coast, USA, all the way down to Sao Paulo and Rio. Santiago in Chile is a possibility. And down in the Southeast Asia, we have Kuala Lumpur connecting with Sydney. So some really quite long stage lengths, as we would call them, or city pair connections, with anywhere between 180 passengers up to 244, depending on the level of comfort and the type of commercial operation that you choose. Many of the new customers for this airplane, and I think we have over 550 orders, something like that. They're putting really quite heavyweight seating in the front of the airplane. So the lie flat business class seats, the newer ones that some of you may have sampled, they weigh a lot. So it has a big implication for the operating empty weight of the airplane and the CG before we start adding fuel. It's a very, very efficient airplane. It's been engineered and reconfigured, including changes to the flap settings for takeoff, to really optimize, find the optimum performance for the city pair choices of the airlines. It has a better cabin, and with that comes connectivity. You cannot get away nowadays on a long-haul airplane without having reasonably reliable Wi-Fi and data-driven feedback back to the engineering operations of the airline, back to the company. And we have the option to use sustainable aviation fuel, and as that becomes more and more mass-produced, it becomes more economically viable, we'll see the percentage of SAF, sustainable fuel, increasing. So back to Jim for some system contrasts between the old and the new.
Thanks, Mark. Yeah, so finished with the marketing slides, and we'll start doing some more technical stuff now. We've got a nice little picture of the airplane here, and we'll walk you through, I think it's almost 10 of the principal modifications to the aircraft, and talk through some of the flight testing that was necessary to deal with that. And as Mark has mentioned, the most significant difference, which allowed us to get that increased range, was on the fuel system. The idea of installing additional center tanks on Airbus single-aisle airplanes is not new. Mark mentioned the 321 long range, where we could install up to 3 additional center tanks. These are actually quite small tanks. They're palletized tanks which could be installed and removed from the aircraft according to the customer's needs. So we can still have one of those on the XLR that can be installed in the forward cargo hold if the customer needs that little bit of extra range. But the principal additional tank is the so-called rear center tank. And this, as Mark mentions, is a structural tank which is located directly behind the center wing box. It's the little green square which you can see on the image there. So if we see what the capacities of those different tanks are, you can see here an overview of the aircraft. The historical fuel system on the A321 is unchanged on the XLR, 2 principal tanks in the wings and a center tank in the center fuselage. But as I say, we've added this rear center tank, and then as an option, that's why it's in gray, the forward ACT, which can be installed and removed as required. You can see the numbers there on the screen, but when you crunch them and have the total volumes, you can see the enormous strides we've made since back in 1992, where we had 19 tons for the Europeans or 42,000 pounds for our North American friends. And we've almost doubled that in actual fact over the years by adding the RCT and the ACT. So that's a really, really significant increase. Now, it's almost certain that when my colleagues at Filton were designing the fuel system, which was inherited from the 320 in many ways in the mid-1980s, they never in their wildest dreams imagined that their fuel system would have to operate on sector lengths up to 11 or more hours. And one of the main concerns we had with the XLR very early on in the flight test campaign was exactly that. How would that fuel system perform if it was exposed to such a long operating time? We're not so worried about pumps running for 11 hours or valves operating correctly after 11 hours. We can test that in the lab and run fatigue testing. It's no problem. The principal concern was actually about temperature. As you can see, the fuel is located in the wing tanks, and the wing tanks are almost the last tanks, if not the last tanks, to be used. We keep fuel in the wings for as long as possible to reduce the wing bending moment. And that means that those wings getting chilled at high altitude cruise for 11 hours can also cool down the fuel. And we need to make sure that the fuel does not get to a significantly low temperature that we start to have issues with freezing. So a very, very early objective in the test campaign was literally take the aircraft and go flying for the maximum duration possible and see if the aircraft worked. So the guys in the fuel team came to me and they said, Jim, you like doing long flights, because it's true. I've done a lot of long flights for fuel systems in the past. Go away and make it happen. And I said, okay, I'll go away and make it happen. We could be really boring. We could take off from Toulouse and literally fly in circles 40 or 39,000 feet above Toulouse. Or we can perhaps do something interesting. And I got on the phone to our marketing team and I said, do we make something out of this? And you may have guessed what we made out of it by the images which you saw in the video at the start of the presentation. I had been very inspired by pictures like this. If you're a fan of Flight Radar 24, you can find examples like this and much less official examples than this if you look really hard. This was Qantas on the retirement flight of their final 747, who decided that they would draw a kangaroo in the skies off Eastern Australia. But the granddaddy of them all in terms of large commercial aircraft testing is this one. And this is Boeing's effort with the 787. I can't believe I'm saying Boeing in the Airbus symposium room. Something wrong, right? But anyway, we have a good relationship with the flight test department in Boeing, I must say. We work together on a lot of things. So I don't have an issue raising their name. But anyway, this was their effort for the 787. And you can see they were able to take pretty much full advantage of the Northern American airspace, which is a bit of a challenge for us. Because when I went to the air traffic control providers here in Europe and said, what's the biggest space you can give me to draw something? They said, oh, we can give you a box about 300 miles across. This is 2,500 miles across, okay? So not quite the same challenge. So we worked a bit and see what we could do, and we figured that, yes, we could actually draw in the sky a realistically large XLR logo in this box, which was made available to us. This is a military test range off the coast of Brittany. And I jiggled with Google Maps back at home and plotted all of the turning points on the letter you can see there. And I was able to generate a route for our pilots to follow. So you can imagine that when I went to our pilots and said, here you are, 46 waypoints, just go away and fly that, please. They weren't very keen on the idea. They said to me, get it in a format which we can put it in the FMS. So I said, okay, here you go. That is the same data, but in a format which is usable by the FMS. But again, Mark's here, and I can see there are other Airbus pilots sitting here in the room. They will tell you that that would be an extremely long and perilous exercise to enter all that data manually in the aircraft. You can imagine if you get it wrong by 0.01 degrees on one of the waypoint coordinates, it might not be XLR that you're writing in the sky, but something a lot less desirable.
We said no.
So one of the functions of the FMS on Airbus aircraft, but in fact on many commercial aircraft types, is the possibility to upload a flight plan into the FMS system. And very luckily for the pilots, I was able to make that happen. And on the ground before the flight, here's some pictures of the images on the ND, the navigation display of the aircraft, showing how we had those waypoints in. So then it was a simple exercise of going away and flying it. Well, I could spend a whole presentation talking about going and flying it, because in actual fact, to write that image in the sky, bearing in mind we wanted to do it at high altitude for cold fuel temperatures, it took us 3 hours to write that in the sky. Flying the aircraft manually, doing very tight turns to make sure we were getting nice, crisp and neat letters so that our marketing friends would be happy. It was a very unusual piloting task, shall we say, but it did teach us a lot about the handling qualities of the aircraft. And the end result, I think, says it all. So you will have seen that from the video at the start. The XLR we drew at the start of the flight. And by the way, we didn't tell anybody we were doing it. We were a little bit worried that we might not be able to pull it off, so we didn't want to make a lot of noise about it. But by the time we'd finished and we were just switching over from the French air traffic control to the UK air traffic control, the last words that the French air traffic controller said to us was, "You are #1 in the world on Flight Radar 24." And yeah, we subsequently did some press work with Flight Radar 24, and they told us that at various stages on the flight, there were as many as 50,000 people following us in real time. So that was a very interesting lesson to us that really everybody's watching what we're doing. And we have to be careful that we're not doing things which are difficult for people to understand. And it's one of the reasons why we're happy to share these kind of experiences with you. The XLR was only the start of the drawing. We still had to then carry on flying the aircraft. And that's why we carried on with this extremely large circuitous route over Scotland and back down through Central Europe. We finally flew for over 13 hours, which is more than what the marketing guys will tell you. But that's because we have a very light test aircraft. So we were able to do things a bit more than what a customer would do. The average cruise temperature was about 7 degrees below the standard international standard atmosphere temperature. So that was good for the fuel system. And I'm delighted to say that the pumps were still running and the fuel wasn't frozen at the end of it. So we successfully achieved our objective. We even landed with 1.5 tons of fuel left over, which is the regulatory reserve to complete the diversion task. So very, very good early performance of the fuel system. So back to our little image, that extra fuel drove a design requirement to increase the maximum takeoff weight of the aircraft. In the late 1990s, we were hovering at around about 80 tons on the 321, and we've pushed it all the way out now to 101 tons as the maximum takeoff weight for the aircraft, which is clearly a significant increase. And all of that with a wing which wasn't really designed for that kind of takeoff weight. So I won't say much more about the takeoff weight, but you will see in the following examples some of the impacts which that had on our design and the testing which had to be done. One obvious question which comes to mind is, well, what about the engines? Mark told you about the fact that the Neo engines brought us some good fuel improvement. People were concerned that we might need to use more powerful engines, higher thrust ratings, potentially increased fuel consumption. But the fact of the matter is that the existing engines that were certified for the 321neo have sufficient thrust for takeoff performance in the vast majority of conditions which our customers were looking for. So for this initial flight test campaign and for the early deliveries, there is no change in actual fact to the thrust rating of the engines, which comes as a surprise to some people. Nevertheless, we had to beef up the aircraft structure as a whole. The wing is an obvious example, but the rest of the fuselage had to cope with things like shear loads. And as Mark has alluded to, there was a specific modification for the rear center tank. So when we engaged our discussions with EASA regarding the certification basis which we would be using for this aircraft, it was obviously many years before the first flight of the aircraft. We were always very open about our intention to use a rear center tank on this aircraft, and we came to an agreement that we would be able to do that simply using the existing structure of the aircraft. After we had started building the airplanes, there was some discussion, shall we say, in various public fora which led EASA to reconsider their position, and they asked us to improve what we call the crashworthiness of the aircraft. Their basic concern was that if the aircraft was to have a belly landing and the fuselage was pierced in any way, the leaking fuel could potentially be a significant fire hazard, which we can understand. There was a lot of toing and froing, you can imagine, as to what we needed to do. And there were basically two major outcomes to that, which had an impact on the design of our aircraft. One was the need to put a liner in the RCT. So in the original design, it was just a metallic structure. Now there is a secondary skin inside the RCT. So that's a second level of protection. Even if the fuselage is pierced, there's still a liner inside the tank. And the second requirement was to put some protection on the outside of the aircraft, basically a pair of skis, if I use very, very basic language, which had to be put on the outside of the fuselage. The idea being that should the aircraft perform a belly landing, the weight of the aircraft will be taken on these skis and therefore reduce the risk of piercing the fuselage. Now, we couldn't let those skis hang around on the outside, so you can start to understand some of the reasons behind Mark's example of the belly fairing change on those pictures. And we're going to play a little game of spot the difference, but in actual fact, Mark's given the answer away already here, so it doesn't really matter, with some pictures from our personal photo collections. This is Mark taxiing out for the first flight of the second aircraft in Hamburg in 2022. And here is me performing GLS trials at Frankfurt Airport around about 18 months later in exactly the same aeroplane. I'm sure you could all spot the difference, right? I do it again for you. There's Mark. And there's me. So if you've got really eagle eyes, I'll put them back to back. You can see exactly as you saw on the pictures from Aer Lingus, the actual physical impact of that modification, because those skis had to be hidden behind a belly fairing to ensure that the aerodynamic performance was not affected. So a number of impacts for us in the flight test campaign. First of all, was an extension of the flight test campaign. We had already got the aircraft delivered to us in the original configuration, and we had to modify it during the flight test campaign. And that was a case of several months. It's easy when you build it in the final assembly line, but when you have to retrofit it in service, it's a much more complicated exercise. The second is that it obviously modified slightly the weight of the aircraft. So we had to go away and do our performance measurements again to check that there was no issue there. And finally, from an aerodynamic point of view, this additional belly fairing, we needed to check the aircraft had no issues in terms of stability. We're changing the side profile of the aircraft, if you like, and we need to make sure that we haven't changed the characteristics of the aircraft. So all those things, even at the end of the day, looks fairly similar, had a significant impact on our campaign. Mark, it's back to you.
So on to landing gear. The original airplane had a double shock absorber configuration. The new airplane has a single shock absorber. And clearly with the heavier weights, greater kinetic energy, you need to look again at your requirements for wheels, tires, and brakes because of the increase in brake energy. So all of those things have fundamentally changed. Landing gear, nose and main, and the tires as well. MERTO is a max energy to take speed of light. Stop.
Bouge pas, tu es bien.
Taxi clear. See the void. You can see it by the number of people on that final picture. It's a large team to undertake a test like this. It's costly. A lot of people are involved, a lot of planning, and a lot of incremental build-up of braking tests before doing that final MERTO. So we would go to airports with long runways, Lyon, for example, or Chalon-Vatry near Paris, where we would do a build-up in the speed. In Lyon, for example, we did rejected takeoffs at 170 knots, max braking, and then on reaching 50 knots, we would release the brakes and then coast the entire length of the runway with the engines in idle reverse, just to avoid that final injection of energy into the brakes that you see in the real final test. So that's what we have to do to prove that the modified brakes and anti-skid system can cope with the combination of speed and mass on the new airplane. Okay, on to the wing and the movables. So some changes to improve the aerodynamic performance, the takeoff performance and the climb performance. The inner flap is changed from a double slotted flap profile to a single slot. At first glance, you might think big deal, but it makes a significant difference to the performance of the aircraft. You can see the single slots on the upper picture, and if you compare it with the Luftwaffe older A321, you see that has a double slot on the inboard flap. There. The most interesting parts, I think, from the test pilot point of view, are the changes to the flight control system. Like the rest of the A320 family, the XLR is a digital fly-by-wire control law airplane. The older airplanes had mechanical rudder, but with augmentation from the fly-by-wire system. On the XLR, you have an E-rudder, so an electronically controlled rudder. So all three axes of the flight control system are now fully fly-by-wire. Those who fly the Airbus will know that the 320 family has different kinds of computer. You have ELAC, which is elevator aileron computer. We have SEC, spoiler elevator computer. And we have FAC, which is not on this diagram because the FAC, and there are two of them, flight augmentation computers, they've been deleted from the design. So now we're down from 7 computers down to 4. So we have 2 ELAC and 2 SEC. And the control laws that live inside those computers, the software, are fundamentally different to what we had before. They're called generic laws or G-star laws, and I contrast that with C-star laws, which we have on the previous airplanes. And the reason we were able to take advantage of this change in control laws is these laws have been evolving with the design office over the years in parallel with the development of the airplane family. And they were mature enough to put into this new airplane. What's different? In a generic law, you actually have an aircraft model embedded in your control law. So the control laws have a much better ability to predict the behavior of the airplane and how it will respond to external disturbances or flight crew inputs on the stick or on the pedals. So we have a smoother airplane. Some of the feedback from customers on the 321neo hasn't been 100% positive, particularly on the flare law for landing. There's room for improvement there. And Airbus have done this tremendously well on the XLR. It feels like a 350 coming in for the flare. And we spent a great deal of testing time and money and manpower time refining and tuning in real time because on the test aircraft, the flight test engineer at his station can change the values in the equations in the flight control laws, can change the gains in the flight control laws, and change the behavior of the airplane. And it's very interesting from a pilot point of view, because we can fly around the circuit doing touch and goes, and we can make a flare to land under a certain condition of weight and CG. And we can give our comments to the engineers, and we can say to them, can you just give me a little bit more ground effect compensation? Or can you change the value of thrust effect compensation? Because as we come in for the flare to land, we select idle. An unaugmented airplane will pitch down. This airplane is compensated for those thrust changes and for the entry into ground effect. We also have to decide what height above the ground do we want to blend from the normal control law into the flare law. We started at 100 feet and we ended up with 60. So just by flying and repeating, and importantly, more than a couple of pilots, we need to spread the experience amongst the team. Pilots have different gains, and we want to get a nice cross-section of pilot behaviors to make sure we have a good product before it goes to the airlines, where there are thousands of pilots, all of whom are subtly different from each other, even if they're following standard procedures. So this was an interesting development in the airplane, and the end result is really good. And because of that, some of the lessons learned from this program are now being evaluated to see if we can reverse engineer them into the 321neo and improve that to get better feedback from the customers. Enhanced takeoff, or ETOC, enhanced takeoff configuration. When you look at some of the runways that the customers are using, the existing flap settings, and there are 3 for takeoff on the 320 family, in an ideal world, you would be able to fill in the gaps between those flap settings under certain conditions to optimize the takeoff performance, or to carry a heavier weight under a given set of conditions. So now we have selectable slat and flap settings, and we've increased the number of configurations to 5 instead of 3. And we do this by entering a number and a letter into the MCDU, the Multi-Purpose Control and Display Unit, and that talks to the slat and flap control, and we have a greater choice. In conjunction with that, there's an electronic flight bag on the iPad, which is used to find the optimum flap and the optimum thrust to optimize your takeoff. So certain runways that in the past may not have been usable are now open to this airplane, because you have a greater flexibility in selecting where your slats and flaps are for takeoff. With the heavier weight and higher speeds, we also needed a flap load relief system. So if the pilot inadvertently exceeds the speed limit for a given flap setting, there will be a partial retraction until the pilot behaves a little better and reduces the speed in response to a warning. If you exceed the speed limit for the flap, you'll get an overspeed warning. In the meantime, the loads are taken care of by the relief system, and then we can slow down and reconfigure. So here's a video. You'll hear some commentary in the background, but Jim's reduced the volume on the commentary because it's in Icelandic. This is in Keflavik. And if you look at the orientation of the airplane, and imagine in your mind where you think the runway is, and then watch where it really is in the video.
Og hóf svo flugprófanir í Keflavík í morgun. Fyrir svona æfingar reyndust aðstæður sérlega hagstæðar, og takið nú eftir hvernig flugmennirnir beitin upp í vindinn í fluginu og réttara síðan af rétt fyrir snertingu. En hér eru þeir að lenda vélinn í 40 hnúta hliðarvindi 20 metrum á sekundu. XLR-vélinn hóf flugprófanir fyrir 16 mánuðum.
And so we've demonstrated, we don't publish it as a limit, but we give a max demonstrated crosswind of 38 knots with gust included, which should cover the majority of cases for the airlines. The behavior of the airplane you saw there, a reasonably smooth landing, it just highlights how important it is to have a smooth, predictable, repeatable flare law that the pilot can predictably use. Because once we get into decrabbing the airplane using the rudder to align the fuselage with the runway, or to kick off the drift, as we call it, in a crosswind landing, if you're having to work hard in the longitudinal axis and you're having to work hard in the yaw axis, now it's a difficult piloting task. You make the longitudinal task, the flare, simpler and easier, then you actually free up capacity in the brain of the pilot to manage the kicking off of the drift, or to make the crosswind landing better, because we don't want side loads on the landing gear, or not significant ones. So the improvements to the fly-by-wire have a number of benefits, including the crosswind case. Back to Jim for the cabin.
So you might be surprised to see that we go as far as Keflavik for flight testing. You might think that all we do is fly around in circles here in Toulouse, but we're not afraid to go far and wide to meet the conditions that we need. Having said that, Keflavik has been an interesting destination for us over the previous years. We used to go very regularly, as did other manufacturers, but you might be aware there was a flight test incident there to another manufacturer, I guess it's the best part of 10 years ago now, where an aircraft actually crashed. Nobody was killed, but the aircraft was lost. And the Icelandic authorities were understandably rather hesitant about having flight testing occurring at their major international airport after that. So we've had to do a lot of work with them, and I mentioned working with our colleagues Boeing, but we do also work with the other OEMs and the regulatory agencies in an organization called the Manufacturers Flight Test Council, to make sure that we all take a common approach to that so that we can all enjoy the benefits of access to an airport like Keflavik. And the XLR was actually the first aircraft to be able to go back to Keflavik to do flight testing following the conclusion of those discussions. So that was a successful outcome for us. Some words on the cabin. So as Mark said, from a pure flight test point of view, probably not the most exciting part of our job, but at the end of the day, that's what we're selling to our customers. The airlines, and what they are subsequently selling to their passengers. So clearly having some focus on the cabin is a very, very important part of the project. It wasn't a given at the start that we would have an aircraft equipped with a cabin for flight testing, but the decision was taken that it was strategically important to perform some testing on the cabin. There's a little picture here, a little vignette, which talks about this product known as Airspace, which is Airbus's latest offering in terms of the cabin. It's a significant refresh and improvement of the A320 cabin, which has gone through several evolutions in the past, but this is the latest version. You can tell if you're on an Airspace cabin because it feels like you're getting into a nightclub, basically. That's how you'll recognize it. It's also the cabin which offers you these very large overhead bins. We all know airlines have this tendency these days to charge you for luggage, and therefore we're all desperate to put everything in our carry-on baggage rather than pay to put it in the hold. And I'm sure you've all had that terrible call, sorry, it's full, you're going to have to check in your hand baggage now when you've been at the gate. So one of our solutions to that is to increase the volume of the overhead bins, and I don't remember what the exact number is, but in terms of percentage, but there actually now is the possibility to put the bags in a vertical arrangement, whereas you're always historically putting them in a horizontal arrangement. We did have to take into account in the design of the cabin the fact that the aircraft was flying for an extremely long period of time. You may all have had experiences, I hope not on an Airbus aircraft, but on other long-haul journeys of having cold feet or a cold head or finding a draft or something like that. And we were concerned about making sure that the environment for our passengers was going to be comfortable. And that environment goes beyond just being comfortable sitting in your seat. It sounds like a bit of a joke, but if you've got 240 passengers and you're flying for 11 hours, that's a lot of visits to the bathroom to cope with. And there was an issue on the 321 long range when it initially went into service of the capacity of the water and waste tanks being insufficient for those physiological needs. And this was addressed on the XLR, or has been addressed on the XLR, by increasing the volume of both the potable water tank, but also the waste tank. Nothing worse than having to do an in-flight turn back because your toilets are full. And maybe there are some people in the room who can remember that from the early days of some of our long-range products. I can see a gentleman nodding in the back. So actually, the simple fact that we needed to make the waste and water tanks bigger drove one of our significant external campaigns for this aircraft, which was to go even further afield than Keflavik, and actually to visit our friends in Canada in Iqaluit. So Iqaluit is a favorite test place for us, relatively accessible from Toulouse. It's around about 6.5 hours flying. In older days, it would have been known as Frobisher Bay. Maybe that's a name which rings bell for some of the people in the room. But we can go there and relatively regularly get temperatures significantly below -20. So for the testing for the water and waste systems, we were looking for -25. We had sent another of the test aircraft a couple of weeks previously for systems testing, and they had even colder temperatures. And actually, we're working at the moment with our Canadian friends at another cold weather campaign to further extend that low temperature capability of the aircraft to address the requirements of some of our upcoming customers. So Iqaluit's a fantastic place, but it is bloody cold, if you don't mind me using that. And the day this picture was taken, you can see we're all wrapped up warm because with the wind chill, it was minus 43 degrees Celsius when this picture was taken. And I'm pleased to say that even with that kind of temperature, when we flushed the toilet, it worked. So the test campaign was a success from that point of view. But it's perhaps another example of how what could appear to be a very minor change to the aircraft and its design, and indeed from a passenger point of view, a totally invisible change, you don't see the water tank when you get on board, can drive a very large number of flight hours or flight cycles in the test campaign and give the numbers we saw at the start. We also undertook what is known as a functional and reliability test campaign. You might have seen some shots of that in the video at the very beginning of our presentation. So functional and reliability, some of you might be familiar with the term route proving. That was the sort of historic name we used for it. And it comes from a time where there was a genuine question about whether aircraft being used by an airline would actually reach their destination. That sounds like a very dramatic thing to say. Maybe Hugh has got some examples from his time flying on 747s, for example, when he took off with 4 engines and landed with a few less engines working, probably. That was a real issue in the early days of jet transport aircraft, and therefore it became part of the certification exercise to prove to the authorities that if you operated the aircraft like the customer was going to operate it, not like we do in flight test with very specific and regulated circumstances, often on short flights, that the aircraft would actually do the job. And so that became known as the route proving exercise. And over the years, with the evolutions in engine technology, which give us a very, very high level of confidence about the engine operation, it's still become a condition to demonstrate that the aircraft operates correctly. But that's why we've changed it to more functional and reliability. Those are the two names in the title. So the functional and reliability exercise for the A321XLR required us to fly 150 flight test hours. So you can see that's almost 10% of the entire flight test campaign, which was dedicated to the functional and reliability testing. And the rules say that you must operate the aircraft exactly like an airline would, if possible to an airline schedule, and preferably with the participation of one or more airlines. So they really, really have to go and play the game. And when we crunch the numbers, having taken into account some of our other test flights which could contribute to this 150 flight hour requirement, for example, the ferry flight to and from Iqaluit was considered as a fairly standard airline flight, we still had 100 hours left to do during this exercise. And that's where our maturity design office came around the corner. Maturity is an issue for us sometimes when we have a brand new product. We haven't had a chance to operate it over a long period of time in an intense fashion like a customer will. And early in service, we sometimes find problems. Our maturity design office wanted to address those issues in advance. And they said, okay, not only do we want you to do 100 hours, but we want you to do it in a 10-day window. And we don't ever want you to turn off the aeroplane for 10 days. I don't know if there are any airlines which realistically don't power down their aircraft for 10 days. I know about 7 days, but 10 days is a significantly long period of time. And that meant that we had to organize this test campaign in a very specific way. It's silly things like the fact that if you get to the gate at an airport and connect a ground power unit, and then in the middle of the night, the ground power unit falls over, well, that cancels out your hours you've done until then. So we wanted to secure that by leaving the APU running overnight. And there are many international airports around the world who say you can't leave the APU running overnight. There is a noise concern for our residents, for example. So we had to work long and hard with various airport authorities. And you can see on the right some of the destinations where we went to, and you'll recognize Dublin is obviously a link in with Aer Lingus, as we saw at the start of the presentation. The bottom picture is Madrid. I don't have a nice picture of the airplane at Madrid, but I do have a nice picture of my colleagues. And to reinforce something which Mark said earlier on, we're here tonight talking, but this certification campaign is a really intense effort by a very large number of people in Airbus, and it's important to recognize them. And in the middle, you can see what looks like a picture postcard, but this was during lightning visits to Miami. As Mark mentioned, American Airlines are intending to use the aircraft to and from Miami, and we partnered with them and wanted to see how we could get on. it wasn't deliberate that we chose to do this in peak hurricane season, which was quite challenging at Miami. Mark was on some of the flights going in and out of Miami, and I think he has some very memorable stories about sitting on the tarmac at Miami waiting for the hurricane to blow through or for the serious thunderstorms to blow through. So for those 100 hours, what did we do? We did some flying around in circles from Toulouse to Toulouse. So that's the green parts you can see on the diagram there. And we did some operations with customer airlines. So we positioned the aircraft at Dublin. From Dublin, we flew it to Miami with Aer Lingus on board. Then from Miami, we brought the aircraft back to Madrid. So that was Mark with the guys from American Airlines. We then had a day out in the Azores to go and visit other customers in that part of the world. That was one of my flights on the airplane. The aircraft came back to Madrid, flew into Miami, another 2-hour turnaround, flew it back to Dublin again, and finally came back to Toulouse. You can see it's a very, very intense program. But the elephant in the room on this picture is this rather ridiculous yellow line, which you can see going up to the top of the screen. And I feel that justifies a little bit of an explanation. It'll be a final anecdote to bring this presentation to a close. The maturity guys wanted to see some very long flights on the aircraft. And typically they were looking for 11 hours cruise. I showed you earlier on that we were capable of doing 13, but it's more realistic in airline service to think about 11 hours. So they said, do some 11-hour flights. And at one point, we'd quite like you to go to what's called the polar navigation regions. Some of you may be familiar with the inertial reference systems on our aircraft and know that they struggle a little bit, along with our navigation systems, at very high latitudes. And so we've got some procedures and systems in place which allow the aircraft to navigate in a slightly different way when it gets up to that part of the world. And we wanted to go and prove that if we got there and the pilots forgot, like they sometimes do, to flick the switch, that the aircraft would automatically put itself in the polar navigation mode. So where could we go in 11 hours? Well, it was pretty much up to 83 degrees north. And we had about 20 minutes available before we had to turn around and come back down again. So that's the reason for this rather extraordinary flight, which went up to the northern tip of Greenland. And the day before we went, I was on board this flight. I had a quick look because I'm a bit of a space weather geek. I'm a big fan of things like solar flares and solar radiation and knockout effects on the HF systems that I have to test. And I spotted that there was a good chance we were going to see the Northern Lights. And I thought that the communications team might be quite interested in this. I thought about them for writing the XLR. I figured they might like some nice pictures. So I said, you might like to come along on the flight. It's 11 hours, it's all night, you're going to be exhausted. The food will be awful, but you might get some nice pictures. I don't know, can we turn the lights down? On peut baisser la lumière ou pas? I don't know whether our friend up in the room can help us to turn it down, because that's really a spectacular image. And it's not a made-up image or a synthesis image. That really is what we saw out of the window. And on this flight, I will tell a little story now about one of Mark's colleagues. On this flight, we took 3 pilots who were flying for 11 hours. So it was important for them to rotate through and get rest. And one of the guys who came with us was a relatively recently recruited flight test pilot who had a previous life working for Air France on their short to medium haul routes. So he was typically flying 3 to 4 hour flights in Central Europe, and he'd never seen the Northern Lights. And we got him on this flight. We thought it was a good experience for him. And blow me down if he wasn't asleep when the Northern Lights came. We didn't wake him up because we thought he's got to be rested. And when we showed him these pictures, yeah, you can imagine his reaction. It really was very, very spectacular. So you can understand a little bit more behind this title, Written in the Stars, for this lecture. You can see the stars here. This was the one which you saw in the publicity for the lecture. So I picked this picture in particular because it was a very interesting exercise for us to study the geography of the Earth, the geometry of the Earth, and to put to bed the whole debate about flat Earth. So this flight was a night flight. We departed from Toulouse at 9 o'clock at night in September. So 9 o'clock at night in September in Toulouse, the sun is just about set. So it was dark when we took off, and 11-hour flight. So we landed back at 8 o'clock the following morning. Well, 8 o'clock, it's around about an hour after sunrise, maybe an hour and a half. So you would think that we would have spent 11 hours flying in the dark. But you can clearly see on the right-hand side of this picture, and we're still on the northbound leg of the flight here, that there is something bright on the horizon. And that's because we had got so far north by flying up to 83 degrees south, we could actually see over the top of the Earth to see where the sun was shining on the other side of the Earth. So we actually saw a sunrise in the middle of the night over the North Pole. Turned around and it got dark again. And we saw the Northern Lights again, and we got back to Toulouse and it got light again. So a very, very bizarre experience, particularly for the fatigue management for the crews. Our fatigue guys are very interested in that as well. And I wanted to show you a little video which I filmed with my personal phone, so there's no sound and no commentary or anything like that, to show you what that actually looked like when we got up there. So here we are looking out of the side of the aircraft, somewhere near my flight test engineer station, which is in the middle of the aircraft. It's in the opposite direction to the previous picture, so we're now flying north going left. And you can clearly see the night behind us and the day on the left. And if I play the video, you'll see how you can physically understand that the night is just the shadow of the Earth. Any more flat earthers out there? Or I think that's a fairly convincing proof, right? By the way, the guy had been asleep. He was flying there. So he said, "Where's the Northern Lights? I can't see anything." So. And the final picture to show you, and then we'd be more than happy to answer any of your questions, is just to say that, once again, there were a large number of people involved in this flight test campaign. And we had an occasion towards the end of the test campaign to thank a lot of the people who'd been involved by actually getting them on board. They thought they were being thanked. Actually, we were using them as guinea pigs. We took 200 Airbus employees flying around Europe one day to assess what it's like when there's actually 200 people on board the aeroplane and they're all using the toilet and they're all eating and they all want the internet and all that kind of stuff. So we were able to use those hours as part of the route proving exercise. But it was our little way of saying thank you to everybody in Airbus who had contributed to the flight test campaign. And with that, we'd be happy to answer your questions. I can see there's some in the room, so we perhaps start in the room before we go to online. So, and we've got a microphone in the room so that those online can hear the questions as well.
Thank you very much. A short question. You've made some handling changes to the aeroplane and flying control changes. How does that affect it cross-crew qualification with the other aeroplanes in the fleet?
So from the beginning, with the reconfiguration of computers and control laws, there was an objective from the start to minimize the need for additional training. Not to minimize additional training, but to minimize the need for additional training. So you could be flying an XLR on a Monday, and then the next morning you could be flying a 319, an old one, or a Neo, and then in the afternoon maybe a 321, an old one or a Neo. And the handling qualities are similar enough that it's not going to require, or we don't believe it's going to require, with the authorities, the need for additional maneuver training or handling training. But qualitatively, it's a smoother pilot's airplane. Yep.
Online, we have a question from our friends in Derby. Was the flight test done with mock loads and all seats installed, or a bare plane?
I'll take that one if you like. So we did do some testing with a cabin installed, as I mentioned. 200 passengers. If you do a rough back of the envelope calculation, is around about 20 tons of ballast. I'm sorry to call passengers ballast, but that's how it works out. But that still wasn't enough for us to reach the extreme maximum takeoff weight conditions which we had to demonstrate, because as Mark mentioned, some of our customers install cabins which are more luxurious than one we had in our flight test aircraft and which increase the empty weight of the aircraft before we even have the passengers. So we couldn't do that just by putting 200 people on board. And our answer to that is to use a ballast system on board our flight test aircraft. We have the possibility to install ballast tanks on the main deck of the aircraft. Many of them, each ballast tank can carry approximately 300 kilograms of water, which we mix with glycol to avoid any freezing issues if there's a cold cabin event. And according to the number of tanks which we install and the position at which we install them, we can actually cover the whole range of weights and CGs which are required to certify the flight envelope, and indeed go beyond, because you can imagine in flight tests we always go the extra mile before then certifying something which is a little bit within the limits that we've tested. One specificity of the XLR is that for the first time on an Airbus single-aisle program, we felt it was advantageous and more efficient to install what we call a transferable water ballast system. So historically on our single-aisle flight test aircraft, we had these tanks, but they stayed in a fixed position and filling for the whole flight. And if we wanted to therefore test two different centers of gravity in a given flight, we could play with the fuel to move the center of gravity a little bit, but not really reach the extremes of the envelope. So we would have to carry out 2 or even more flights to study different centers of gravity by filling in different tanks. On the XLR, and if you get the chance to visit the aircraft, you'll think you're going into a brewery because that's what it looks like. We installed a set of pipes and pumps linking the ballast tanks. And in real time in flight, we can pump the ballast between the tanks. So for a given all-up weight, we can change the center of gravity and see in real time how that's affecting the behavior of the aircraft. Mark talked earlier on about the fact that we can change the handling qualities of the aircraft from the flight test engineer station. If we leave the tunings the same, we can still change the handling qualities of the aircraft by changing the center of gravity. And that was another way of getting through this large number of hours and flights in a very efficient way. Yeah, there's a microphone question in the room.
Very nice presentation. Thank you. My question is, for those roughly 1,500 hours of flight tests, how many do you reckon you would have on the simulator?
Oh, good question. It's true that, yeah, probably. That's not a bad figure. I'm a systems guy, so I spend a lot of time in the simulator because I can test a lot of my things. A flight management system is an excellent example. I spent 5 hours in the simulator this morning and everything's validated. I don't need to go flying for it. So my ratio might be a little bit higher than what Mark's saying, but it's true that we can do a lot of development work in the simulator in advance, and the number which Mark's suggesting is around about 3 or 4 to 1. And the other thing to bear in mind is that a lot of that happens a long way upstream before we even start playing with the aircraft. We can start working on a first guess at what we think the flight control law could be and fine tune it. If it turns out to be an absolute mess in the simulator, then we stop and we go in a different way. So yeah, 3 or 4 to 1 is about right, but a lot of it upstream rather than in parallel with the flying.
Another question online. What is the ETOPS range of the XLR?
That's a very good question. I wish I'd brought my certification guys with me. I mean, basically, the single-aisle aircraft at Airbus, I believe, are all 3 hours ETOPS as a baseline. What we have done on top of that, I honestly don't know. I'd have to go away and find out the answer. And if you note down the person's contacts, then I'd be happy to answer it. 180. Okay, that's the baseline. Thank you. That's obviously one of my Airbus colleagues here, so appreciate that. Yeah, there's one at the front here from Kevin.
So my question is, what were your conclusions about flying a single-aisle aircraft for upwards of 12, 13 hours from a flight deck perspective?
In terms of the environmentals, so humidity, temperature,
fatigue, things like that. Yeah.
If you fly it in a way that's representative of how an airline would fly it, and we're not bound by the fatigue management rules that an airline would have, but those long flights that you saw, we crewed them as if we were an airline. So we would take representative crew rest periods on the longer flights, as you would do with a 350 or a 787, similar behaviors. And we've not had any adverse comments. I mean, the long-range wide-body airplanes tend to be a little bit more comfortable in terms of cabin altitude and humidification of the air. So they're always better because they're originally designed for a much longer range flight. But within the scope of what we did, it was satisfactory. Yeah.
I might add to that as I mentioned in the function and reliability testing, we did have airline crews on board, so we were able to get very direct feedback from them. And it's not just Airbus internal marketing speak to say that the Airbus pilots find it fine. It's exactly what the customer pilots said as well. So before even delivering to them, we've got that positive feedback.
I should make the point, so for example, I did a Madrid to Miami with American Airlines pilots guests, and we integrated them into the crew. They were operating crew. They weren't there in an observation capacity. They were part of the crew.
There is an option to add it, but it's not baseline. Yeah.
I have a question on the wing. You increased the weight massively, but you said you didn't increase the wing. So you have to provide lift, you have to alter the angle of incidence, then you increase the drag. Can you give a comment on that, please?
Well, I can't give you a number. You'll understand it's obviously very highly sensitive, commercially speaking. But what I can say is that we meet all the requirements of the certification authorities, and we also meet all of the commercially agreed objectives with our customers. That range of 4,700 miles, we've been out there and proven that it's done it, even if inevitably, yes, from a pure physics point of view, there is a change in the aerodynamics. The bigger issue, and as Mark mentioned, is not so much about cruise, it's actually about the takeoff and climb performance, and that's what drove us to change the flaps, the inboard flaps, and there clearly there's a difference between the wing, which was originally designed for around about 80 tons back in the day. So yeah, in cruise hasn't been found to be an issue for us, and the benefits we've seen from the flap settings are more than just actually ensuring that increase in takeoff weight. It's also about, as Mark says, gaining access to airfields where previously you might have been performance limited. So it's a win-win for us as far as we can see.
I have a question online from Garrett Wood. Crosswind limits are given as 38 kts demonstrated. What would have been the highest crosswind encountered during flight testing?
Well, in fact, it's that number. It's 38 knots, including the gusts, and we call that the max demonstrated. So that's the strongest wind that we've encountered in the tests, and we present that to the regulatory authorities and the customers. And any imposition of a limitation, that becomes either a regulator issue or it can be imposed by the airline itself. But we demonstrate the capability of the aircraft. And that's where we stop. We don't impose a limit in the same way that we would impose a Mach number limit or an airspeed limit. We don't do the same for crosswind. We demonstrate a crosswind, and that's as far as it goes.
Yeah. Where there would be a formal limitation is in things like autoland, for example, which is a specific set of constraints. There would be a crosswind limitation. But as Mark says, in terms of normal manual handling of the airplane, then it's just a demonstration that we make, nothing more than that.
I have another question online. When flight testing, would the plane have any flight attendants or helpers, since the flight seems to be extremely long? Also, would that mean that did you have meals aboard during the flight testing?
So I can answer the flight attendant question. You're looking at him. In our setup in flight test, all of the qualified flight test personnel on board have received training in cabin work. So that could be first aid training, it could be evacuation training, it could be a minimum in how to pour a cup of coffee without spilling it all over a person's pair of trousers. But more seriously, that's declared in our operations manual that, like an airline, per tranche of passengers, we have to carry somebody who is only responsible for looking after the passengers. But rather than specifically having trained cabin crew for what is a very punctual need in our testing, we prefer to give additional training to people like flight test engineers, or even pilots can do the role if they really fancy it. Yeah, from a purely regulatory point of view, yes, we're covering the safety of our passengers, but not with trained cabin crew. Having said that, when we do brand new aircraft types, the most recent example would be A350, we do work with airline cabin crews to get their very early feedback on the design choices we've made. And you can find some very good videos published by Airbus on its channels on social media, which shows that kind of work. I can remember flying with Virgin Atlantic on the A350-1000. airlines like Lufthansa, Air France on the 350-900 and so on and so forth. In terms of food, we do provide food on board. Yeah, we have to make sure that not only the passengers but also the crew have got enough energy to do their work on the flight. I'm not pretending it's first-class food, but it's certainly edible. I mentioned the work we do with Flight Radar 24. They actually sent a journalist to come with us on this polar flight where we had the Northern Lights. And you can find online on the Flight Radar 24 website, not their tracking website, they actually have a blog website, the story of that flight from that journalist's point of view, and also some video footage which he took. And much to our surprise, he was a lot less interested about the technical aspects of the flight than he was in the food which we provided with him. So you can actually see what we ate on that flight.
I wanted to ask you, how is the crew rest area managed on a small fuselage like the one of the A320?
So the crew rest area is at the choice of an airline. There is nothing stopping an airline from dedicating some space in their cabin to make a crew rest area if they want to do that. But it's true that on a single-aisle aircraft, that would represent a significant loss in revenue space for them. It's passenger seats which they can't sell. Because you have to remember that the XLR is used for two different roles. It could be used for very long-haul flying, but in the gaps in the schedule, which, for example, a round trip to the States would allow, you can then use it for a regional flight in Europe. That's what Iberia are doing with their aircraft, for example, or Aer Lingus, they're doing the same. And if you had a crew rest area, that's a few less seats, which you could be selling on your intra-European flights, for example. So a more typical arrangement, and that's the arrangement we had on our cabin aircraft, is actually to allocate some of the seats, the passenger seats in the cabin as a crew rest area. And on our cabin aircraft, we actually had two such areas. We had an area in the business class and an area in the economy class at the rear, specifically because we wanted to see what the working conditions were like. And it's little more complicated than simply drawing a curtain around those seats. They're the same seats as the passengers get. The one thing we do is ensure that the airflow into those areas is permanent and sufficient, so that there's nobody suffocating inside a sealed off area, that kind of thing. But that's a choice that the airlines have to make in terms of their configuration.
Wouldn't the courting be against the EASA regulation for a barrier in the cabin?
I don't know the answer to that question. I don't believe so, because it's a design which is quite commonly found in actual fact. It's not an issue. There has to be regular checking by the other members of the cabin crew that nobody's struggling inside the curtained off area, that kind of thing. It's not a hard barrier. It's a fabric curtain, you know, so I don't think there's any physical requirement.
Yeah, no, because I remember that for some business class arrangement, on FAA side it was allowed, but on EASA side it got blocked by, because of...
It's indeed a complicated area, but I'm not aware of any restrictions which we had on that. So.
Okay. Thank you.
You're welcome.
I have a question online from Johan Thomas. Could you precise a little bit what was the feedback about the flare in company?
I'm guessing that question relates to the 321neo and the contrast between that one and the XLR. So the story of the flare law goes back to the development of the Neo, where time was perhaps of the essence in the development of the Neo family. As you all know, at that time, Airbus and Boeing were competing for solutions on the single-aisle market. And so we didn't really have the luxury of time to tune it to be a beautiful flare law. It meets all the certification requirements, but when you then create a new variant of the airplane, in this case the XLR, and you have the time and the resource to really tune it, and you have the new control law configuration, the generic laws, which give you a more powerful ability to adapt the values of the control laws, or the fixed values in the control laws, to the flight phase and all the variations of weight and center of gravity. Once you end up with a really high-performing flare law in the XLR, we're very conscious we don't want to have a big contrast between this one and the airplane you might fly the next day, the 321neo. So, and that's why Airbus has made the choice to look at improving. There's a work package underway already. It's budgeted and underway to improve the 321neo in the flare phase. But the XLR, I'd be very surprised if we make any changes to that. I mean, we've still got inputs to come from other regulators, some of whom are with us. And it'd be very interesting to get feedback on back-to-back flying between the variants. I'm not sure if that's in your plan. No. I know the FAA was taking a great interest in that. I think they may have done it already. I'm not sure.
I can't remember. To be very honest with you.
Yeah. So, but it raises an important point. If you have an airplane and you create a new variant of it, and there are perceptible differences, you have to consider what is the difference and what's the magnitude of the gap, if you like, and what do you need to do about it. In theory, we could do nothing about the older airplane, but the Airbus way of doing things is to make improvements where it's wise and it's possible to do it. And with the learnings from this program, albeit that we can't put generic laws in the 321neo, but we can take some of the learnings on where do you blend the law, how close to the ground do you have to be before you blend in the flare law, and how do you deal with variables as you approach the ground, like the ground effect, like the thrust effect. So that's where the focus is for the improvements.
I have a last question online. Is the A321 LR still in the Airbus catalog, or is it substituted by the XLR and it's an optional front center tank?
The A321 long range is in the Airbus catalog still, because it gives customers who want it the flexibility to install or remove the additional center tanks, which I mentioned. We have some customers who use their aircraft in the summer for long haul traffic across the North Atlantic, and then in the winter they remove the ACTs and use the same aircraft for shorter haul traffic within Europe or the Middle East, for example. You can't do that with an XLR because the rear center tank is a structural tank. It's an aircraft which is more dedicated to long range flying. So yes, it's still in the catalogue, still available, and still, as far as I'm aware, I don't have the numbers, but still selling rather well. Yeah. I'm aware we're short on time, Hugh, so perhaps we need to draw the questions to end, and I think you've got a few more slides to share here, so come on up.
Come to your thanks later on, I think, but this is just to show our future program. The one we have next month, which is on the 12th of February, fairly soon. And thanks to Richard Forstall, who is a friend of Jean-François Jeunesse. Perhaps some of you know him. He is an interesting character, shall we say, and you can see that from the title. It is Disruptive Innovations in Space Technology. And so we're looking forward to an interesting talk, which I think our president may be interested, David, if you're moving into the space era. Anyhow, so will be on the 12th of February. Later on, we had a full program, but unfortunately, two of the people we had, their companies no longer listed. That was Lilium and also, sadly, Reaction Engines, who we've had in the past, but they've dropped out. So we're looking for other speakers now, which I'm sure we'll find fairly soon. And going through way in the distance for a more social thing, we have an annual dinner on the 27th of June at the Hotelier. Say again?
Okay. It was operated by Reaction.
Oh, which say again?
Le Hotelier no longer works.
Oh,
It's finished.
are we going to have
Sorry.
Well, I should liaise with Hillary
It
David,
closed.
who's
It
running
closed definitively on the 15th of December. But I have been looking at other places for us.
All right. Well, I should have liaised with Hillary, who
You have
does
to
our.
give me the chance. I'll
organises
talk
our-
to you about it, but
our,
I have some ideas.
Very good. Well, we're going to have an informal dinner somewhere in June, and I hope you come because it's been enjoyed by the people who've been able to come. Apologies for not checking with Hillary first. Or anyhow, well, why don't we say, well, thanks again to Jim and Mark. Now, actually, well, no, it's a contentious discussion, which Bob will comment on. We have provided with thanks. I know we have